Hi everyone, my name is Azar Osmanov. I am third year chemical engineering student at Bakohir Oil School. Today my presentation is about non-Newtonian fluids. Let's start. Here is the content of the presentation. It will consist of the following parts: Newton's law of viscosity, general outlook to the non-Newtonian fluids, forms of non-Newtonian fluids, industrial properties. Before start the main part of the presentation, I wanna just give some brief information about Newton's law of viscosity. Viscosity is the physical property that characterizes the flow resistance of sample fluids. Newton's law of viscosity defines the relationship between shear stress and shear rate of fluid subjected to mechanical stress. The ratio of shear stress to the shear rate is constant for given temperature and pressure, and it's defined as the viscosity or coefficient of viscosity. What's non-Newtonian fluids? Non-Newtonian fluids don't follow Newton's law, and their viscosity, basically speaking, ratio of shear stress to the shear rate is not constant and depend on the shear rate. Non-Newtonian fluids have viscosity that change according to amount of force that's applied to the fluid. The viscosity change as force applied change. In non-Newtonian fluids, the relation between shear stress and shear rate is different, can even be time dependent, and a constant of viscosity cannot be defined for Newton's law, non-Newtonian fluids, but it's possible for Newtonian fluids. In contrast to Newtonian fluids, non-Newtonian fluids display as a non-linear relation between shear stress and shear rate. If viscosity of fluid increase as shear rate increase, it's shear thickening. A common example for shear thickening is a mixture of cornstarch and water. Fluids are shear thinning if the viscosity decrease as shear rate increase. Shear thinning fluids, also known as pseudoplastic, and they are present in industrial and biological processes. Common examples for this include ketchup, veins, and blood. You can observe it from graph 1, figure 1. Different forms of non-Newtonian fluids. So, the viscosity of non-Newtonian fluids can take various forms, and some of which are outlined in figure 2. They are Bingham plastic, dilettante pseudoplastic, and yield pseudoplastic. Bingham plastic is a material that behaves as rigid body at low stress. The behavior is exhibited by suspension of solids in liquid, paint, and so on. Dilettante fluids exhibit shear thickening properties. The fluid viscosity increases the ratio of applied shear stress. A mixture of cornstarch and water is a good example for dilettante fluids. Pseudoplastic fluids such as paint and ketchup exhibit shear thinning properties, where the viscosity decreases the rate of applied shear stress. Yield pseudoplastic fluids are similar to the pseudoplastic fluids, with the exception that they are exhibit yield stress level. And industrial properties of non-Newtonian fluids. All plastics are combination of non-Newtonian and Newtonian behavior. At the lower shear stress, the plastic is non-Newtonian, but as shear rate increases, the plastic tends to exhibit a Newtonian behavior. This happens because with the increase in shear rate, polymer molecules start to entangle from each other and then start to align themselves in their direction of flow. After certain shear rate, most of molecules are aligned in the direction of flow, and increasing the injection speed does not further affect the viscosity. That's the end. Thank you for your attention.